With that understood, I want to do a few things. First, I want to go through some of Dr. Tour's talking points and explain how some of them are reasonable while most are not. It is clear that his religious views cloud his capacity to interpret research on this topic, as does his gross overestimation of his own abilities. While it is true that as an organic chemist, he has a dramatically enhanced capacity to understand this topic over a layperson, it is still not his area of research. Pretending a synthetic organic chemist is best equipped to understand the origin of life just because they build small molecules is like pretending that a particle physicist is best equipped to understand organic chemistry, something which Dr. Tour would vehemently disagree with. Origin of life research is a complex, multidisciplinary field. It is not his expertise, nor in his authority to flippantly dismiss, as he attempts to do.
Well, Professor Dave, how are you better equipped to explain the origin of life? We have all our limitations, but Dr. Tour, in his field of expertise, he's very well equipped at least to address the question which he best does in regards of the origin of the molecules, of the complex molecules. And whatever he says in regards of this field, he says it based on his experience, his knowledge, his understanding, his expertise, and anyone is entitled, in my understanding, to listen very carefully about what he has to say in regards of the origins of life and take him seriously. So the mere fact that he is specialized in his specific field says nothing in regards that he cannot give an informed opinion in regards of abiogenesis as a whole.
Oftentimes with reasoning that ignores basic facts in biology. Second, I want to go through some of the very common but embarrassingly invalid talking points that uneducated creationists use when discussing abiogenesis. Dr. Tour is much too smart to use these, but because I hear them all the time and we are on the subject anyway, there are a couple greatest hits that deserve to be dissected. And lastly, I want to briefly highlight where research in abiogenesis stands, mainly to demonstrate that most detractors have absolutely zero capacity to comprehend it, but also to show that while we don't know precisely what happened billions of years ago to get life started, we have a lot of it mapped out with multiple cogent possibilities for each step.
Well, Professor Dave, that is interesting. I would like to cite to you what Steve Benner has to say in regards of this issue, and I think what he said in regards of this is very pertinent. Let me quote him. He writes, in the paradoxes in the origin of life, we are now 60 years into the modern era of prebiotic chemistry. That era has produced tens of thousands of papers attempting to define processes which molecules that look like biology might arise from molecules that do not look like biology. For the most part, these papers report success in the sense that those papers define the term, and yet the problem remains unsolved. So you can cite as many papers that you want, and I am listing over 40 different approaches and attempts to explain how life could have emerged prebiotically on the early Earth. And none of these proposals have a really compelling explanation or give a scenario which actually makes sense. So this is just a straw man, Dave.
And to those with a reasonable understanding of biochemistry, it's not far-fetched in the slightest. So to begin, let's check out more of what Dr. Tour has to say.
When one looks at a typical textbook, one will see some prehistoric pond and molecules, and those molecules coming together and forming a cell, and those cells coming together and some slithering creature coming out of this pond. That is fallacious. There is no truth in that.
This is one version of a talking point Jim brings up a lot. He hates how in some textbooks you see a primordial soup of molecules, some lightning, and then all of a sudden a cell is there, and then maybe a lizard crawling onto land or something like that. To call this a complete view of abiogenesis and evolution would be absurd, but absolutely no one proposes this. This is something that a lot of creationists do. They refer to what is very obviously a textbook meant for middle school students and pretend it represents the pinnacle of scientific thought on the matter. Sixth graders have zero capacity to understand biochemistry, so their textbook doesn't have any biochemistry in it. A college level textbook will not look like this, so this is a dishonest talking point.
We do not know how to build even a simple bacterium. The simplest bacterium with its 256 protein coding genes, we have no idea how to build it. First of all, we don't know how to build the molecules, the 4 classes of molecules that are needed for it. We don't know how to, even if we had those 4 classes of molecules, assemble them even into the simplest of bacteriums. We don't know how to do that.
So there are two enormous problems with this. Jim is constantly talking about how we don't know how to make the 4 classes of biomolecules, which are nucleic acids, proteins, carbohydrates, and lipids. This is ridiculous.
No, this is not ridiculous, Dave. Just in the beginning of the video, Professor Tour, he said that the quest is how these building blocks were made prebiotically. And he pointed out that that is the problem. And you say this is ridiculous, but that's literally the truth. And I can cite you all the problems which are which exist today in regards of the prebiotic or origin of these basic building blocks of life. And that is really a pertinent point, which I fully agree with Professor Tour. Let's have a look. As you can see, in regards of the implausibility of the prevital RNA and DNA synthesis, I have listed here 27 different problems which are plugged in abiogenesis research. This is just in regards of the prebiotic synthesis of RNA and DNA. So rather than science coming closer to explain how DNA and RNA were synthesized, the problems which are unlisted, they are getting greater and greater. So this is a huge problem. And in amino acids, in regards of the prebiotic synthesis of amino acids, it is the same problem. There is a huge list of different problems which are unsolved. In regards of phospholipid and cell membrane synthesis, it is the same situation. There is a long list of problems which are unsolved. And in regards of carbohydrates, that's the same thing. That's the same problem, the same situation. So these are huge unsolved problems.
We type in the sequence we want on the computer, let the machine run, and we can get a DNA strand of any sequence of nucleotides we want, or a protein of any sequence of amino acids we want. Carbohydrates are a bit more complex since, despite consisting of the same monomer over and over, they can connect in a number of different ways. So synthesizing polysaccharides is trickier, though we are making progress with that too. And lipids like triglycerides can be synthesized easily. Any biomolecule is easy to synthesize.
No, Professor Dave. As I explained right now, that is not true. The abiotic synthesis of the basic building blocks is a huge problem.
Jim knows this. He's a synthetic chemist. What he probably means is that we haven't seen these biomacromolecules form spontaneously outside of a biological system.
Yeah, and that's the only question and the only issue that you should actually address, Dave, not the one where we polymerize the basic building blocks in the lab. That is not the issue at all. So you are diverging here to the real issue and the real problem.
But that's not what he says. He does not make the distinction. And
Of course he did. Right in the beginning, when you showed what he is saying, he was mentioning prebiotic synthesis. So you're strawmanning Dr. Tour now.
this seems deliberate on his part. Next, he talks about us being unable to assemble a simple bacterium. This is absolutely irrelevant.
That is absolutely irrelevant, Professor Dave. That is the crux of the issue. That is what abiogenesis research is about, to make life from non-life, starting from the basic building blocks. And that is a huge problem. We are not even close to have an explanation how the basic building blocks synthesized prebiotically without the enzymatic machinery of modern cells. We are not even close to have a slight understanding how the transition occurred from prebiotic synthesis to enzymatic synthesis of the basic building blocks and then of a complete cell. So this is very relevant, and Professor Tour is right to outline that. And you should not say that this is irrelevant. It is absolutely irrelevant.
The instructions for assembly are encoded in the DNA.
Yes, and where did that information come from, Professor Dave? That is as well an abiogenesis problem. And we know that the smallest free living bacteria has about 1.3 million nucleotides. And these bacteria, they are not smaller like Mycoplasma, because Mycoplasma, which is often cited as the first eventual reference organism, it is a pathogen. It is living as a host in humans, and it gets the basic building blocks like amino acids from the host cell. And what we need to do is to take a free living bacteria which synthesizes the 20 amino acids, and that bacteria has about 1.3 million nucleotides. So where did the information come from to make that genome with that size? And if we try to understand how that occurred naturally by unguided means, that is a chance in 1 to 10 to the over 700,000 of power. That is in the realm of the absolutely impossible. That's a huge problem. And of course, you are simply ignoring to elucidate that and to address it.
And DNA predates all bacteria. The issue is to arrive at the bacterial genome, not to somehow be able to assemble a complete bacterium from its fully formed constituent parts.
Of course, it has to be explained everything in order to have a first self-replicating cell which kick-started life. Everything has to be explained, not only the information in the genome, but how from there on the whole machinery to transcribe and translate the information and then make proteins and then assemble them into metabolic pathways, and a fully fledged and self-replicating cell occurred. And that is the problem, Professor Dave. And you cannot minimize it and say, oh no, only the origin of the information of the first genome has to be explained. No, everything has to be explained. And you know well how huge that problem is.
Because nature doesn't do that either.
Of course, nature does it. We have life, and life knows how to create a fully self-replicating living cell. So that is the problem that has to be explained. So don't minimize the problem, Professor Dave.
Nature assembled some dramatically simpler precursor, which was self-replicating and also self-improving.
Well, this is also a huge problem. How did self-replication even start? We have no explanation for this, Professor Dave, and I can cite the very origin of the first organism saying in regard presents at least an appearance of a paradox, because a certain minimum level of complexity is required to make self-replication possible at all. High fidelity replication requires additional functionalities that need even more information to be encoded. The crucial question is how the Darwin eigencycle could have started. How was the minimum complexity that is required to achieve the minimally acceptable replication fidelity attained? In even the simplest modern systems, such as RNA viruses, replication is catalyzed by complex protein polymerases. The replicase itself is produced by translation of the respective messenger RNAs, which is mediated by the immensely complex ribosomal apparatus. Hence, The dramatic paradox of the origin of life is that to attain the minimum complexity required for a biological system to start on the Darwin eigenspiral, a system of a far greater complexity appears to be required. How such a system could have emerged is a puzzle that defeats conventional evolutionary thinking, all of which is about biological systems moving along the spiral. The solution is bound to be unusual. The origin of life, or to be more precise, the origin of the first replicator systems and the origin of translation remains a huge enigma, and progress in solving these problems has been very modest. Well, this is also a concept that there was a gradual chemical evolution and there were protocells which then suddenly became self-replicating, living cells. So the cell is irreducibly complex, and this is even acknowledged by secular scientists like Graham Curran Smith, for example. He pointed out we can see that at the time of the common ancestor, this system must have already been fixed in its essentials, probably through a critical interdependence of subsystems. Roughly speaking, in a domain in which everything has come to depend on everything else, nothing can be easily changed, and our central biochemistry is very much like that. So, in order to have a first a self-replicating living cell, Professor Dave, you need the basic building blocks of life, you need energy in the form of ATP, and you need information, a minimal quantity of information stored in the first genome. And if even one of these is missing, then you have no life. How do you explain that this occurs gradually by a stepwise evolutionary fashion? That is simply not conceivable. And chemist Wilhelm Huck, professor at Radboud University in the Netherlands, said, a working cell is more than the sum of its parts. A functioning cell must be entirely correct at once in all its complexity. And I can give you an example. For example, if you do not have topoisomerase, which disentangles DNA, how do you have a cell starting to replicate DNA? It simply doesn't work. You need to have a minimal proteome fully operational and working together right from the start. And if even one of these proteins is missing, you have no life. What happens if you don't have a membrane protein which imports molybdenum, for example, which is essential for the course of many proteins which are essential for life to start? If you don't have the import channels for iron, for sulfur, for molybdenum, and many other things, you do not have life. So that notion that life could have started with protocells and a gradual chemical evolutionary trajectory, that is nonsense.
So this is not a valid argument. It's also incredibly anti-intellectual. We can't make planets and stars either. Does that mean nature can't have made them spontaneously?
There would be no inherent information in the DNA. But even if we gave them the DNA in the structure that they wanted, they wouldn't know how to put all the components together.
This is just nonsense. He is saying there is no information inherent in the DNA.
Yes, that's not nonsense, Professor Dave. It has to be explained how the right sequence of nucleotides came to be prebiotically. And as I said previously, for having a free living, self-replicating bacteria, it takes 1.3 million nucleotides, which have to be in the right sequence in order to synthesize the proteins which are required for a first living cell. How did that information be stored in DNA? And it goes much deeper than that. You need to have the materials, RNA, DNA, RNA. You need to have the basic building blocks. You need to string them together, to polymerize them together prebiotically. That's a huge problem. And how do you get 1.3 million nucleotides in the right sequence without direction? That's in the realm of the impossible. That's a huge abiogenesis problem. And you know that, Professor Dave. But rather than acknowledging it, you say that's nonsense. No, that's not nonsense. That's a problem which you have not addressed, and nobody has addressed it. And it's not explainable by natural means because the odds are far too great and far too big that it could be possible by prebiotic unguided means.
when DNA is inherently information because of the way genes code for proteins when expressed. Jim is way out of his element when it comes to informatics. Then he says something unintelligible about how, if the DNA was provided, we still wouldn't know how to put the bacterium together. Again, this is ridiculous because the DNA is literally what contains the instructions to put the bacterium together.
Okay, so where did the machinery come from to transcribe and translate the information and then make proteins, Dave? This machinery is also based on information stored in the genome. So, what came first? The information to make the RNA polymerase and the ribosome, or this machinery that actually expresses the information in the genome to make the proteins, these proteins which express the information? That is a chicken and eggs problem, which conveniently, of course, you are not addressing the problem, but it's a huge problem. And we have many chicken and egg problems in the cell where everything has to come together all at once in order to kickstart life.
I find it hard to believe that Jim does not understand how gene expression works, so this may just be dishonesty on his part.
No, Professor Dave, that has just been dishonest of your part to not explain and address the chicken and egg problem.
You say, well, we can make the liposome, the cell membrane. We cannot. There's over 40,000 lipids have been identified in cell membranes. You want to take some simple ones? It's not just individual lipid membranes. You have to have the inside and the outside of the membrane have to be different. You have to have this huge array of proteins, that transmembrane proteins.
More straw man arguments.
No, again, Professor Dave, Professor Tour is right on this. The cell membrane needs to have right from the start the membrane proteins which form homeostasis, which form energy gradient and homeostasis in regards of calcium. The calcium content inside of the cell has to be 10,000 times less the concentration than in the outside, otherwise signaling cannot occur, and that had to occur everything all at once. So this is a huge problem. What came first, the cell membrane or the membrane proteins which provide all this kind of requirements?
Jim is talking about cells as they exist today.
Yeah, and exist today. They had to exist when life started.
And in describing the plethora of surface proteins, it sounds like he may even be talking specifically about eukaryotic animal cells.
No. Prokaryotes also require membrane proteins. So you're just deflecting here in regards of that problem, Professor Dave. Who is being dishonest here?
Something he brings up all the time, the complexity of a cell. And he will talk about microtubules and different organelles and wonder about how that all could have come together by chance.
Okay, Professor Dave, there is another huge problem of the transition from prokaryotic to eukaryotic cells. There are no true intermediates in the prokaryotic to eukaryotic transition. More than 20 different versions of endosymbiotic theory have been presented in the literature to explain the origin of eukaryotes and their mitochondria. The origin of eukaryotes is certainly one of the early evolution's most important topics. Throughout 150 years of the science of bacteriology, there is no evidence that one species of bacteria has changed into another. Since there is no evidence for species changes between the simplest forms of unicellular life, it is not surprising that there is no evidence for evolution from prokaryotic bacterial to eukaryotic plant and animal cells, let alone throughout the whole array of higher multicellular organisms. The organizational complexity of the eukaryotes is so much greater than that of the prokaryotes that is difficult to visualize how eukaryotic could have arisen from any known prokaryotes. In eukaryotes, the mitochondria produce most of the cell's ATP. Anaerobic glycolysis also produces some, and in plants, the chloroplasts can also service this function. The mitochondria produces ATP in their internal membrane system called the cystae. Since bacteria lack mitochondria, as well as the internal membrane system, they must produce ATP in their cell membrane, which they do by two basic steps. The bacterial cell membrane contains a unique structure designed to produce ATP, and no comparable structure has been found in any eukaryotic cell. So this is a huge problem, Professor Dave. And as well, the size of prokaryotic cells is 15,000 times bigger in terms of volume and 1,000 times bigger in terms of diameter. And then the mitochondria has a genome of about 20,000 nucleotides, while the smallest bacteria has 1.3 million nucleotides. So how did this reduction of size occur? And also the genetic code in the general genetic code is different than mitochondrial genetic code. So how did that transition occur? That is also a huge problem. So I would say that the endosymbiotic theory is bunk.
The first protocell didn't have to have a single surface protein. It didn't have DNA, it had RNA. It was unrecognizably simple compared to any cell that exists on Earth today.
Well, such a thing would not be life, and there is no reason to believe that there were membranes, vesicles filled with RNA. As said before, how do you even concentrate the number of RNAs required to have a minimal genome? These are huge unsolved problems. And if it would have happened in an aqueous solution, how did you concentrate the RNA inside of the membrane?
Jim seems to want abiogenesis to explain how life as it exists today could have come about spontaneously, and that's a straw man for the record books.
No, as said previously, that's not a straw man. You have to explain how self-replicating cells started, fully formed with a minimal proteome, genome, and metabolome. That is not a straw man, Professor Dave.
No one proposes anything resembling that. Pretending the first protocell and eukaryotic animal cells are the same thing is like pretending a shack made of twigs is the Taj Mahal.
Well, again, nobody's talking about eukaryotic cells, Professor Dave. What we are trying to explain is how the smallest, most simply possible life form could have emerged. And as I said before, that is not simple at all. It is extremely complex. A bacterial cell which is free living, which synthesizes all the basic building blocks of life and the 20 amino acids, requires at minimum 1.3 million nucleotides. Again, where did that kind of information come from?
There is no comparison. The complexity of eukaryotic cells evolved slowly over several billion years.
That is just a baseless claim, Professor Dave. You have no evidence for this. Science has no evidence for this. It's just evolutionary storytelling.
Once biological processes were already firmly in place. This is well understood by any biology undergraduate student.
We need the nucleic acids and then the homochiral systems that for the amino acids, which then need to be built up into protein structures. We need the carbohydrates, which have to be built up into the polycarbohydrate structures. And then we need the lipids, which also are chiral. All of these we need in homochiral form. We don't know how to do this in any prebiotic type scenario at all.
This is a reasonable point, or it would be if Jim was not a highly educated chemist that should know about existing research in this area. It is a fact that many biomolecules are homochiral, like L amino acids, and this begs explanation because stereospecific synthesis, where we get only one molecule of two possible mirror images, is difficult to do, even with sentient chemists driving the reactions. But Jim has not dug deep enough, as there are a multitude of plausible explanations for this.
No, Professor Dave, there are no plausible explanations for this. Let's see what current science has to say about the topic. Enantiomers are molecules that are mirror images of each other. Today, amino acids and sugars exist in only one enantiomeric form in most biological systems on Earth. This homochirality remains one of the greatest unsolved mysteries to scientists. Fact is, and you know that, Dr. Dave, that living cells, they know how to only synthesize amino acids which are left-handed to transaminase reactions. On the prebiotic Earth, the enzymes that do that selection did not exist. So there is no known selection process to sort out left-handed from right-handed amino acids. And there is another problem which you probably have, I don't know if you knew that, but it is claimed that about 500 different amino acids were extant on the prebiotic Earth, but life used only about 20, maybe 22 amino acids. So how was that sorted out from that pool of over 500 amino acids? There was no selection mechanism to join only the ones used in life to one place and then starting to polymerize them. That's a huge problem, and I don't think that you are honest about this and addressing it in an adequate manner. The fact is that you need right from the beginning only left-handed amino acids and right-handed nucleotides, and there is no selection mechanism. That's an unsolved problem, and there is no solution inside Dr. Dave. We don't know how that could have occurred prebiotically.
For example, carbohydrates, which is the main class of compounds. These are the units that hook together DNA. These are the units that have identifying aspects on cell structure. These are the units that the cell is going to need for the energy of life. Carbohydrates are kinetic products, meaning that if they should form, they would decompose. They decompose over time. In relatively short amounts of time, they decompose. The very reactions that make them, unless somebody is there to pull them out, to fish them out, to stop the process and to put them in a bottle under inert conditions in a freezer, and not just one, there's many different types you have to do this. They end up going through a process of what's referred to as caramelization, meaning that they polymerize. They polymerize. The very aldol reactions that were used to make them just continue. And you get polyaldols, you get polycondensation reactions, and they caramelize. Or they undergo, with formaldehyde, which is a presumed prebiotic chemical, they undergo rapid Canizarro reactions. So the aldehyde is oxidized to formic acid, and this nice carbohydrate that you made has just been reduced. So the aldehyde from the carbohydrate has gone back to an alcohol. So there's competing reactions. So time does not solve the issue.
So this is an abbreviated example of one of Jim's favorite talking points, which is that long spans of time make abiogenesis less likely rather than more likely because biomolecules have a tendency to degrade. But there are some problems here. First, he is presuming that nature might synthesize one component of life one time and that's it. There's no reason to believe this. If conditions are allowing for some molecule to form or polymerize, then it can be doing that all the time. It polymerizes, then degrades, then polymerizes again. Whatever biochemical process the molecule will later be involved in, the fact that it degrades is irrelevant if it is constantly being formed as well, and even more irrelevant once self-replication came about, such that a mechanism is in place to continually build copies given the raw components.
So let's see what Steve Bednar has to say about this issue, Dr. Gray. So Stephen Bednar writes in the science paper Paradoxes in the Origin of Life, the Asphalt Paradox. Systems given energy and left to themselves devolve to give useless complex mixtures, asphalts. The literature reports to our knowledge exactly 0 confirmed observations where replication involving replicable imperfections, evolution emerged spontaneously from a devolving chemical system. It is impossible for any non-living chemical system to escape devolution to enter into the Darwinian world of the living. Such statements of impossibility apply even to macromolecules not assumed to be necessary for RI evolution. And here Steve goes a little bit more extended into that issue where we read. An enormous amount of empirical data have established as a rule that organic systems, given energy and left to themselves, devolve to give useless complex mixtures, asphalts. Theory that enumerates small molecule space as well as structure theory in chemistry can be construed to regard this devolution a necessary consequence of theory. Conversely, the literature reports to our knowledge exactly zero confirmed observations where replication involving replicable imperfections, evolution, emerged spontaneously from a devolving chemical system. Further, chemical theories, including the second law of thermodynamics, bonding theory that describes the space accessible to sets of atoms, and structure theory, requiring that replication systems occupy only tiny fractions of that space, suggest that it is impossible for any non-living chemical system to escape evolution, to enter into the Darwinian world of the living. Such statements of impossibility apply even to macromolecules not assumed to be necessary for evolution. Again, richly supported by empirical observation, material escapes from known metabolic cycles that might be viewed as models for a metabolic first origin of life, making such cycles short-lived. Lipids that provide tidy compartments under the close supervision of a graduate student, supporting a protocell first model for origins, are quite non-robust with respect to small environmental perturbations, such as change in the salt concentration, the introduction of solvents, or a change in temperature. So Steve Banner is absolutely no positive in regards of this issue, and so he disproves your claim, Dr. Dave.
He also refers to a specific reaction called the Canizarro reaction, which requires strongly basic conditions. He knows these conditions are required, and he knows the ocean did not provide such strongly basic conditions, so I don't know why he brings this one up at all. Beyond this, it is pointless to cite every extraneous reaction that was potentially happening at that time, as useless products were simply not selected by nature. Nature utilized the structures that were useful for information storage and metabolic activity, and it happening at that time, as useless products were simply not selected by nature.
Well, there was no selection process at that point, Dr. Dave. Why would atoms have selected useful products for life to start? Did they have foreknowledge to know which molecules that later on their upfront would be used for life to kickstart life? That is just not true. And the fact is that these biomolecules, they would have just been in such a low concentration. How could they have been joined in an aqueous environment to start to react one with each other? That is simply far feasible to understand how that could have happened. So this is not a plausible scenario at all.
Nature utilized the structures that were useful for information storage and metabolic activity and ignored the rest. Dr. Tour very clearly demonstrates his inability to lecture on this topic when he talks like this.
Well, first of all, as I said previously, molecules and atoms, they do not have the urge to become alive. So why would they select the useful products from the ones that are not useful to kickstart life? That is just nonsensical, Dr. Dave. There was no selection process. There were just random chemical reactions on the prebiotic earth. That's all.
He is comparing the chemistry he is familiar with in his lab to what happened in the ocean billions of years ago, ignoring the stark differences in setting and principles involved.
The most recent abiogenesis hypotheses are the hydrothermal vents hypothesis. And what does Stanley Miller have to say about this? I have a very simple response to that. Submarine vents don't make organic compounds, they decompose them. Indeed, these vents are one of the limiting factors on what organic compounds you are going to have in the primitive oceans. At the present time, the entire ocean goes through those vents in 10 million years. So all of the organic compounds get zapped every 10 million years. That places a constraint on how much organic material you can get. Furthermore, it gives you a time scale for the origin of life. If all the polymers and other goodies that you make get destroyed, it means life has to start early and rapidly. If you look at the process in detail, it seems that long periods of time are detrimental rather than helpful. And there is, of course, also the concentration problem. How do you join to one construction site the biomolecules required to kickstart life? These materials were very diluted in the ocean. There is no mechanism to join them together at one place. That's correct, Dr. Dave. That's a huge problem. All these lab experiments, they are guided by chemists, but on the prebiotic Earth, there was no guidance at all. So how could that have happened without guidance? Again, Dr. Dave, there was no self-replication and no natural selection at this stage. But let's suppose that were even a case.
All of the structures he is referencing simply weren't the ones that were selected. That's all there is to it.
If you had 400 million years to get to a certain point in the synthesis of a particular class of compounds, now you run out of material. Anytime you do synthesis, you run out of material, even when you've optimized yields, and you got to go back to the beginning. Well, say it took you 400 million years to get to a certain point on a synthesis. Now you have to go back and make more. But how do you go back and make more? Because nature never kept a laboratory notebook. If you had 400 million years to get to a certain point in the synthesis of a particular class of compounds, now you run out of material. Anytime you do synthesis, you run out of material, even when you've optimized yields, and you got to go back to the beginning. Well, say it took you 400 million years to get to a certain point on a synthesis. Now you have to go back and make more. But how do you go back and make more? Because nature never kept a laboratory notebook.
This is just perplexing. He acts like nature was given a few dozen molecules to play with, made some stuff, and then ran out of material, as though the ocean is a tiny reaction flask with a few milligrams of reactant. This is ridiculous.
Now, what is ridiculous, Dr. Dave, is that you make that claim. The building blocks of life are extremely complex. You need to sort out 20 amino acids from the pool of over 500 supposedly extant on the early Earth. RNA and DNA was not extant. They have to be synthesized by very complex procedures. You know this, and there were no prebiotic mechanisms to do so. That applies as well to carbohydrates and phospholipids. These are extremely complex compounds, and they were not simply free floating in the ocean or so. They have to be synthesized, and they have to be synthesized in the necessary quantities in order to have enough of the materials. As Dr. Tour said, they were not simply laying around in the ocean. Just to have the nucleotides, to have a minimal genome, you need the millions of them. So where did they come from?
Molecules are mind-bogglingly abundant. There was no shortage of simple molecules to act as building blocks. The difficult part is explaining how they came together to form biological systems.
Yeah, that is a second problem. Even let's suppose that you have these materials at one building site, concentrated, you need to polymerize them. And polymerization is a very complex process in the cell that is performed by the ribosome, for example, which polymerizes amino acids. But the polymerization mechanism was not extant on the early Earth. And that's a huge problem. The bondage problem of the molecules to make polymers is a huge problem. And you know this.
That there were enough molecules around to do it many times is not a problem whatsoever. Whatever processes came about, they were ongoing, and there were plenty of molecules in the ocean to perpetuate them.
So there is another problem, Dr. Beck. Amino acids used for life have amino groups and carboxyl groups. To form a chain, it is necessary to have the reaction of bifunctional monomers, that is, molecules with two functional groups, so they combine with two others. If a unifunctional monomer with only one functional group reacts with the end of the chain can grow no further, at this end. If only a small fraction of unifunctional molecules were present, lone polymers could not form. But all prebiotic simulation experiments produce at least 3 times more unifunctional molecules than bifunctional molecules. Michael Denton writes in Evolution, a Theory in Crisis. To grasp the reality of life as it has been revealed by molecular biology, we must magnify a cell 1,000 million times until it is 20 kilometers in diameter and resembles a giant airship large enough to cover a great city like London or New York. What we would see would be an object of unparalleled complexity and adaptive design. On the surface of the cell, we would see millions of openings like the portholes of a vast spaceship, opening and closing to allow a continual stream of materials to flow in and out. If we were to enter one of these openings, we would find ourselves in a world of supreme technology and bewildering complexity. The complexity of the simplest known type of cell is so great that it is impossible to accept that such an object would have been thrown together suddenly by some kind of freakish, vastly improbable event. Such an occurrence would be indistinguishable from a miracle. The cell is a veritable micro-miniaturized factory containing thousands of exquisitely designed pieces of intricate molecular machinery, made up altogether of 100,000 million atoms, far more complicated than any machine built by man and absolutely without parallel in the non-living world. So you think this is a small feat, Dr. Dave? I think this demonstrates in a marvelous way how God is far more intelligent than the brightest minds of humanity. And that gives honor to God. If you think that it would be a greater feat to scramble a living cell together by chance, just throw the molecules on a prebiotic earth and then wait, I don't see how that could be a sense, how that could make sense to believe that this would be a greater feat, in special if we know that chance doesn't have that kind of capacity to make complex machines, factories made upon the precise instruction of blueprints and instructional complex information.
So that covers Dr. Tour. Now let's talk a bit about what far less educated people do with precisely the same agenda on this topic. The first talking point I hear constantly is some variation on the probability of a protein forming spontaneously, and they always assign some seemingly arbitrary number they found somewhere, like 1 in 10 to the 120th power, or something ridiculous. People who put forward this kind of talking point are always confused as to whether they are talking about a mechanism by which proteins can form spontaneously in general, or whether they are talking about the probability of a protein with a specific amino acid sequence forming. To clarify, proteins are polymers made of amino acids. There are 20 different amino acids, and these undergo dehydration reactions to link together and form long chains, which we call polypeptides.
That, Professor Dave, is already a huge problem. How did polymerization occur on the early Earth without the machinery that does bond amino acids together in the ribosome? There was no such mechanism, and science has no idea how that could have happened on the prebiotic Earth. And there is another problem. As you mentioned correctly, this synthesis happens through dehydration. That means that water is removed. That means that this synthesis could not have happened in water. So where did it happen? On the surface of the Earth? If that would be the case, the joints, they would suddenly disintegrate through UV radiation. So this is a huge problem which you conveniently neglect to mention.
And in living organisms, polypeptides are called proteins. There are different ways this polymerization can take place, both in biological systems and the laboratory. None of these methods were available before life existed, so we must try to understand how it happened initially. And we will elucidate this a bit later. But putting a quantitative probability on such a process arising is totally ridiculous. So what most people mean when they say this is that it is highly improbable that a specific protein with a specific amino acid sequence will form, so as to produce a protein capable of carrying out some specific biological function. Here, the number is easy to calculate. Each amino acid residue is 1 out of 20. So we just raise 20 to the power of how many amino acids there are in the chain. Even considering a small protein of 100 residues, we can see how big this number gets. But the problem is that this manner of discussing probabilities is very misleading. Nature did not set out to generate a particular amino acid sequence. The process was completely random.
The process was completely random. Can you imagine this? So, in a sequence space of 1 to 10 to the 100 of power, life did suddenly figure out which sequence that was functional. How could that happen, Professor Dave? This is just a fantasy scenario which bears no rationality in real life. I can give you an example. In order to have a functional protein, you need to have amino acids. In order to have the amino acids used in life, you have to select the right ones amongst over 500 that occur naturally on Earth. To get functional ones, you need to sort them out between the left-handed and right-handed ones, the Homochirality problem. Only left-handed amino acids are used in cells. There is no selection process known besides the one used in cells by sophisticated enzymes which produce only left-handed amino acids. Amino acids used for life have amino groups and carboxyl groups. To form a chain, it is necessary to have the reaction of bifunctional monomers, that is, molecules with two functional groups, so they combine with two others. If a unifunctional monomer with only one functional group reacts with the end of the chain can grow no further at this end. If only a small fraction of unifunctional molecules were present, long polymers could not form. But all prebiotic simulation experiments produce at least 3 times more unifunctional molecules than bifunctional molecules. The useful amino acids would have to be joined and brought together at the same assembly site in enough quantity. There are 4 different ways to bond them together by the side chains. If bonded to the wrong side chain, no deal. The formation of amide bonds without the assistance of enzymes poses a major challenge for the theories of the origin of life. Instructional, specified complex information is required to get the right amino acid sequence, which is essential to get the functionality in a vast sequence space. Amongst trillions of possible sequences, rare are the ones that provide function. Before amino acids could join into a sequence providing functional folding, it would disintegrate if hit by UV radiation. But even if that would not be the case, most proteins become only functional if they are joined into holoenzymes, where various amino acid chains come together like lock and key. If that would occur, the tertiary and quaternary structure in most cases would bear no function without the insertion of a cofactor inside the pocket, like retinol in the opsin pocket forming rhodopsin. But even if there would emerge a functional protein on the early Earth, by itself it would be like a piston outside the engine block of an automobile. Many proteins bear only function once they are integrated in an assembly line, producing sophisticated molecular products used in life. But even if we had an assembly line of enzymes producing a functional product, what good would there be for that product if the cell would not know where that product is required in the cell? For example, chlorophyll requires the complex biosynthesis process of 17 enzymes lined up in the right order, each producing the substrate used by the next enzyme. But chlorophyll has no function unless inserted in the light harvesting antenna complex used in photosynthesis to capture light and funnel it to the reaction center. But even if that complex chlorophyll and the light harvesting complex would be fully set up, they have no function without all over 30 protein complexes forming photosynthesis, used to make hydrocarbons essential for all life advanced forms. Now, let's suppose all this would assemble by a freaky random accident on early Earth. There would still be no mechanisms of transition from a prebiotic assembly to cell factory synthesis.
Countless different sequences were generated. It was only when a protein ended up having some particular function by chance that its production was preferred statistically, and it began to propagate with greater frequency than other sequences. Furthermore, its functionality began as approximate and was refined over many cycles of optimization.
Well, why would that be? Why would there be an optimization, in special if there was yet no life and evolution? Molecules, they have no goal to optimize.
Ending up as the astoundingly efficient enzymes we see today, billions of years later. So a discussion of the probability of a particular sequence forming is utterly meaningless. Here's an analogy that should help drive this point home. Let's say 10 people are very low. One talking point I hear a lot is that the spontaneous formation of life violates the second law of thermodynamics. This is ridiculous, and people who say this have no idea what this law states.
Once again, I disagree with you, Professor Dave, and this is why. Life, in any form, is a very serious enigma and conundrum. It does something, whatever the biochemical pathway, machinery, enzymes, etc. are involved, that should not and honestly could not ever get off the ground. It spontaneously recruits Gibbs-free energy from its environment so as to reduce its own entropy. That is tantamount to a rock continuously recruiting the want to roll it up the hill, or a rusty nail figuring out how to spontaneously rust and add layers of galvanizing zinc on itself to fight corrosion. Unintelligent simple chemicals can self-organize into instructions for building solar farms, photosystems 1 and 2, hydroelectric dams, ATP synthase, propulsion, motor proteins, self-repair, p53 tumor suppressor proteins, or self-destruct, caspases, in the event that these instructions become too damaged by the way the universe usually operates. Abiogenesis is not the issue that scientists simply need more time to figure out, but a fundamental problem with materialism.